Okay, all right, we're going to start the next section. The next sections are on bones and muscles, and that's what will be covered on your final and on your final practical. So we're going to start with bone and bone structure, bone tissue, and then I'll be posting other PowerPoints on different bones throughout the body, the skeletal system. So we'll go through the skull, all the bones there, and the holes, and all the different bones in the body, and different major landmarks and things for that. But so we'll start with the bones and bone structure. Let's put this in a slideshow for you. Play from the start. Okay. So the skeletal system, it includes the skeleton, all the cartilage and bone ligaments that make up the structure in the body, the support system in the body. Okay. It adds support. It is a storage for minerals and lipids as well. So we have yellow marrow in the bone as lipids, and then we have calcium and other minerals that are stored in the bones that we can take out of the bone or deposit in the bone if we need to store it. We also have red blood cell production, and we use the skeletal system for protection. So like our rib cage can protect our internal organs, and we have our bones to use as leverage when we are moving our body and using our muscles. So there's different classifications with the different types of bones. So we have sutural bones or Wormian bones, which are flat bones within a suture. And in the next slide, I'll show pictures of it. So there's small bones within a suture, usually in the skull. And then irregular bones like the vertebra. We have short bones like the carpal bones or the tarsal bones. So those are the ones in your wrist or in your ankle, in your foot. And then we have flat bones, so like your sternum, your ribs, your scapula, so your shoulder blade, and then the bones in your skull, they're all flat bones. And long bones like your femur or humerus, tibia, fibula, things like that, those are long bones. And then sesamoid bones are small and flat, round. So like your patella is the biggest one. Okay, it helps to add leverage to the muscles. So they can move your skeletal system easier. Okay, but you also have sesamoid bones. You can have them in your feet or throughout your body in different joints. But, here's a similar picture of what's in your book. Now this is an older image, but you can see the sutural bone within that suture. Okay, it's just a small round bone within the suture. Vertebra and irregular bone, the short bones and the carpal tarsals. And then flat bones, long bones, and sesamoid bones. Okay. So those are the classifications. And then we have some terms that you should be familiar with as we go through it. So a process is a bump or projection. A ramus is an angle in the bone. Okay, so you have your mandibular ramus. Okay, where the bone has an angle, or you have your pubic ramus. Okay, where the bone is angled. And then there's sinuses, which is a chamber, a foramen, which is a passageway, fissure, which is like a cleft. So it's not really a hole, but it's more of a narrow cleft or a deep cleft. And then you have the meatus, which is like a channel, and then a canal, which is kind of a channel too. And then you have we'll talk about the shaft of a bone, the diaphysis. You have your head and neck. Okay, and then on your femur, you have a trochanter. You have a greater and lesser trochanters, which are just large projections. For your humerus, you have things called tubercles and greater and lesser tubercles. Okay, those are, again, just rounded projections. You have tuberosities, which are rough projections. okay, usually in response to stress that muscles are putting on it. So there's like your deltoid tuberosity here. Your deltoid attaches in here, so your deltoid pulls on the bone right there. So because of that stress, more bone is laid down right there, so it develops this bump. So tuberosity, tubercles. A line is a low ridge here. A spine is like a point or a process. Crest is this ridge, okay, iliac crest here. We have fossa, which is like a depression here. Sulcus is like a groove, a narrow groove. We have facets, which are like articular surfaces, and then condyles are rounded articular surfaces. So those are just general terms. So if you get familiar with what those kind of mean when we talk about the greater and lesser tubercles, you'll know what a tubercle is. So that may help you out when we're talking about the specific points on bones. Again, more general terms, diaphysis. Okay, that's the shaft of the bone. Okay, diaphysis, this long, extended tubular shaft. And then you have the epiphysis, which is the area at the end. Epiphysis. Then the area in between is the metaphysis. Okay, this is usually where you kind of have the growth plates in between. All right, compact bone. Compact bone is dense bone, so you can see this denser part along the outside of the shaft. Okay, that's compact bone. Then you have medullary bone, which is in the medullary cavity, which has the spongy bone in it. Okay, or trabecular bone. Okay, so we'll see a picture of that too. So that's not different. It's different from compact bone. So you have more spongy bone in the head and neck, where there's force. The forces are coming at different angles. Okay, so they're kind of cross bridging with the fibers of the bone, and as opposed to along the diaphysis here, you have that compact bone because there's only force going up, going down the shaft. Okay, so you can have that compact bone aligned in one direction to add strength in that one direction. Okay, whereas in the end, in the head and the neck, okay, you have stress going different directions. So you have different trabecular bone there. Okay. So characteristics of bone, you have a bony matrix. It's dense due to the deposit of calcium salts and protein fibers. You have matrix that contains different bone cells. So we'll talk about the bone cells and which are called osteocytes, and they're in the lacuna. So we'll look specifically at the osteocytes, the osteoblasts, lacuna, the canaliculi, which are the narrow passageways. We talked about that in the different connective tissues when we talked about tissues. Okay, so you have the canaliculi, which are little outcroppings of the cytoplasm from the osteocytes that kind of draw out nutrients from the blood vessels in the central canal. And we'll see pictures of that in a minute. So the periosteum covers the outer surface of the bones. And you have an outer fibrous layer and an intercellular layer. Okay, and then there's different makeup of what actually is in the bone. So you see that it has salts and sodium, magnesium, fluoride, different things within the bone that we can store there, or the body can grab out of the bone when it needs it. So bone cells, we have osteogenic cells. So these are the stem cells. These differentiate into the osteoblasts. Okay, this is important for repair, and we find it in the inner layers of the periosteum and the endosteum. Okay. Then we have osteoblasts. These are what make the bone matrix. They produce new bone matrix. It's called osteogenesis or ossification. We'll look at that in a second. And then osteocytes are the mature cells. So we can see in this picture, we have the osteoblasts, okay, and they start to form bone matrix around itself, basically. And then once it's formed that matrix all the way around itself, then it's mature and it's an osteocyte. Sorry about that. Osteocyte. And then It has these outcroppings of the cytoplasm, which are the canaliculi, okay, to reach out towards the blood vessels to gain nutrients. Okay. And then we have osteoclasts. Okay, osteoclasts break down bone and remove bone matrix. Okay, these are larger cells. You see they have a lot of nuclei, so 50 or more nuclei. So they break down bone and cause osteolysis or resorption of bone. So this is when we have bone remodeling. Okay, when we have an injury or we have different stress placed on a bone. Okay, when we have like when we're babies, our acetabulum, where our hip joint is really, really shallow because there's been no force or stress placed into that joint. But as babies grow and they start to crawl and walk, they develop that gravitational force that pushes down in that joint, pushes the femur head up into the acetabulum. So you have remodeling based on that stress, and it becomes deeper. So you have this deep hip socket that originally wasn't there, but when gravity starts to work on it, you remodel and reshape that bone. So to remodel bone, you have to take away bone and lay down bone. So osteoclasts take bone away, and osteoblasts, okay, deposit more bone. Okay. So those are bone cells. Right. So in compact bone, we have an osteon. Okay, this is a basic functional mature unit of compact bone. So we see in this picture the concentric circles here of lamellae, and then we have the canaliculi, which are those little lines coming out from that central canal, the central canal where the blood vessels are. And then canaliculi going out towards these darker oval spots here. That's the lacunae with the osteocyte within it. Okay, so this is a basic functional unit. Okay. These central canals go up and down along the shaft of the bone, perpendicular or parallel with the shaft of the bone. And then you have what's called perforating canals or Volkmann's canals, which go perpendicular to the surface. So they run side to side as opposed to up and down. They run side to side. They're blood vessels and that allow, or canals that allow for blood flow out to the sides. We have we talked about the lamellae. This is circumferential lamellae. Lamellae are found on the outer and inner surfaces of bone, where they're covered by the periosteum and endosteum. So we see here, we have the circumferential lamellae around here, and there's the periosteum here. And periosteum is on the end. We'll look at a better slide of the periosteum that has the two layers, the fibrous outer layer and the intercellular layer here. And then around each osteon here, we have the central canal and then the concentric lamellae around the central canal here. And the endosteum is in here around the blood vessels there. So we see the endosteum, and there's endosteum here as well from the compact bone to the spongy bone. Okay. So look at that. All right, so spongy bone, or this is made up of trabeculae. So we have the trabeculae and the spongy bone. Okay, you see that there's they're kind of cross-bridged in here. There's kind of a matrix of lamellae. This provides that strong, that strength in multiple different directions. Okay, so the shaft, we have the shaft, we have the tension up and down the shaft on the lateral side here. Okay, but along the head and neck here, we have, see that stress comes in at a different angle here. So we have to have this cross-bridging in the trabecular bone with the trabeculae. There's no capillaries in here. Okay, they get the nutrients from diffusion, and it contains, so we have the spongy bone in the head and neck, but also through this medullary cavity, and that contains marrow. So most of this is red marrow, which produces blood cells, okay, and the blood vessels within the tissue deliver nutrients to osteocytes by diffusion. We talked about that. And then yellow marrow is adipose tissue. So you have two different types of marrow: red marrow that produces the blood cells, and then yellow marrow, which is adipose tissue. So that's your energy reserve, which I mentioned on the first slide there. Okay. Periosteum and endosteum. Periosteum is the outer layer of the bone. Okay, it separates the bone tissue from the surrounding tissue, and this is continuous with the joint capsules and synovial capsules. Synovial joints, like your knee joint, is a synovial joint. Okay, so the periosteum runs continuous with the joint capsule, and different like tendons and ligaments can actually embed fibers within the periosteum. It's called perforating fibers or Sharpie's fibers, which are collagen fibers that are incorporated into the bone tissue from tendons and ligaments. Okay, so this strengthens the attachment of the tendon or ligament into the bone, because it actually has the fibers that go into the periosteum. And the endosteum is the incomplete cellular layer of the medullary cavity. So what we looked at here, so this is an incomplete layer, so it's not continuous. We have those osteoclastic activity. There's kind of space and holes in there, but this layer is the endosteum. This is active during bone growth and repair, remodeling, and it covers the trabecular spongy bone on the inner surface. It also covers the central canal. So the central canal has that lining of endosteum too. Okay. And so here's a picture of both of those. We have the periosteum here, for the inner cellular layer, and the outer fibrous layer. Okay, and then we have here, you can see the little perforating fibers that come through. Okay, this helps the ligaments and tendons attach into the bone better. And then on the endosteum here, they're showing you on the inside of the medullary cavity here, where there's holes through it. So it's incomplete cellular layer, but you have this osteoclast with the multiple nuclei causing osteoclastic activity, osteolysis, breakdown of the bone matrix during remodeling. Okay. Or if we need, say we need calcium or another mineral or something, the osteoclasts need to activate to break down the matrix of the bone to release the calcium or other minerals. Okay. So ossification is the physical process of bone formation. We have calcification, which is the deposit of calcium salts, and calcification takes place during ossification. Okay, so there's two different types of ossification. There's endochondral and intramembranous. So endochondral is like for your long bones. So this is most of the long bones in your body. We have blood vessels that invade the center of the shaft and start an primary ossification center there. And then we have growth longitudinally, so along the length of the bone, which is called interstitial growth. And this interstitial growth grows towards the ends of the bone, okay, grows lengthwise. And then we have appositional growth, which increases the width of the bone, okay. So this endochondral ossification replaces cartilage. So your bones are all cartilage until this ossification happens and the bone replaces the cartilage. Intramembranous, this is most of the flat bones in the body. So your mandible, clavicle, skull are all intramembranous. Okay, so it replaces mesenchyme or fibrous connective tissue with bone. Okay, so that's where we have soft spots in our head. We have still that fibrous connective tissue and no bone there yet. Okay, so as we have more intramembranous ossification, our skull, will close up those soft spots as it replaces that connective tissue with actual bone. Okay, so there's a better picture, I think, now in your book. I think it may be in a spotlight. There's an older picture of the endochondral ossification. You have this blood flow, blood vessel that enters here, starts the primary ossification center. You have an interstitial growth towards the length, along the length of the bone, and then you have a secondary ossification center start at the epiphysis. Okay, more blood flow enters here on the ends here, and starts to replace the cartilage along the epiphysis, and then we'll slowly work towards closing at this epiphyseal cartilage here, this metaphyseal plate in between the two. So the growth plate area, that metaphyseal plate here is the last portion to close. And then you also have that appositional growth. You can see as this continues to ossify, it gets thicker. Okay, that's the appositional growth. All right, and these are X-rays of it. Okay, you can see where there's still epiphyseal cartilage here, and then as it ossifies, you have that epiphyseal closure where that line disappears. Okay. This is the intramembranous. So you have these mesenchymal cells, which differentiate into osteoblasts and start to form that bone matrix. And this occurs in the mandible or the different bones in the skull. And as it ossifies around the different blood vessels. So you have this kind of remodeling around the blood vessels. All right, so the blood supply, nerve supply, we have that nutrient artery and vein that come in and establish that first primary ossification center in the middle of the diaphysis here. And then we have metaphyseal artery and vein that goes in at the metaphysis and provides the epiphysis with blood flow. And then we have periosteal vessels, which innervate which supply the periosteum of the bone, the superficial osteons here in the compact bone and periosteum. Okay. Again, we talked about bone remodeling. This is continuously recycling and renewing the organic and mineral components of the bone matrix. So all that osteoclastic activity along the medullary cavity or along different parts of the bone, and then osteoblastic activity laying down new bone matrix. It's called Wolff's Law. It relies on certain stress. Where there's more stress on a bone, more bone is laid down, basically. Okay, so so let's talk about some of the minerals and hormonal effects. So the minerals, we have calcium, phosphorus, magnesium, fluoride, iron, magnesium within the bone. And we talked about calcitriol when we talked about the integumentary system, okay, where it helps create vitamin D and is important in calcium and phosphate ion absorption in the digestive tract. Vitamin C is important in collagen synthesis. And you need vitamin C to produce collagen. And then we also have vitamin A, K, B12, and vitamins A stimulates the osteoblasts, so that makes new bone matrix, and then vitamin K and B are required for proteins in normal bone. And then we have a table here. Look at this table to see all the effects of these different hormones on the skeletal system. So calcitriol, okay, that promotes calcium and phosphate absorption. Okay, the growth hormones and the sex hormones activate osteoblastic activity. Okay, and the thyroxine, thyroid hormone, activates osteoblastic activity. And that makes new bone matrix. And then the parathyroid hormone, parathyroid is the main way we maintain calcium levels in our blood. So this causes osteoclastic activity to release calcium and increase calcium in our blood. Calcitonin is from the thyroid, and that will inhibit the osteoclastic activity and reduce calcium. in the blood. So the next ones here show how those two work. So parathyroid hormone, we have low calcium, so parathyroid hormone then activates osteoclastic activity to release more calcium, absorb more calcium in the gut, and conserve more calcium and not excrete as much from in the urine. So we increase calcium levels in the blood, whereas the calcitonin from the thyroid gland senses the thyroid gland senses a high calcium, so calcitonin then causes calcium to release slower from the bone. Okay, now it decreases osteoclastic activity. It absorbs calcium more slowly and excretes more in the urine to then decrease calcium levels. So again, go over that little table and make sure you know those hormones, because I'll ask one on the test. So you'll need to know it. There's I think a spotlight on different fractures in your book now. This is an older picture, but you can go over and make sure you know these. I don't remember, there may be one question on the test. There probably will be one on the practical of x-ray that shows a certain fracture, and you just got to name it, what type of fracture it is. Go over the different types of fractures, what they look like, and then last but not least, a couple of terms: osteopenia, okay, inadequate ossification of bone. Osteopenia, and then osteoporosis is where there's a reduced bone mass, and so that there's compromise of normal function. Okay, so we see the picture here of normal bone, and then you see this osteoporosis where there's a bunch of holes and the density is just way down. So that fracture can occur more easily, things like that. So normal function can occur. You can't hold your body weight up, basically. But what prevents against osteoporosis is weight-bearing activity. So using resistance training, weight training, bands, that kind of stuff, being upright, rebounders, trampoline, that kind of stuff, all puts more force into the bone. And so your body responds to stress on bone by laying down more bone. So easy way to prevent osteoporosis, just do weight-bearing stuff. Osteoclastic activating factor, this is a secondary osteoporosis where cancer causes a decrease in bone density. So cancers in bone marrow or breast tissue or other tissues leads to secondary osteoporosis. So that's the quick introduction with bone tissue and bone structure. Next, we will go over the appendicular and axial skeletons and go over all the different holes in the head, all the different bones in the body, and different landmarks and stuff. There's a lot, so you'll need quite a bit of time to memorize all of those, and we'll work on, I'll talk through how to orient some of the bones, at least in person. That was part of the practical, was to orient a certain bone, tell if it was the right or left, and tell what bone it was. So I'll give you landmarks to orient different bones, and figure out what bone it is and where the different landmarks are and stuff like that. So next will be the axial skeleton, and then we'll do appendicular. All right.